pulling down a model pulling down a model from Hugging Face is a good option. Designing your own, again, those work really well. Then you need a Dockerfile that installs your dependencies, and as well as you need some scripts to, some shell scripts to run your training scripts when it comes time to do so. You then deploy it to Elastic Container Registry. Then you can initiate your training job with Sagemaker and deploy the created model to an endpoint. So we'll go with a simple example here. So suppose you have a client or are working for someone and they have a task for you to accomplish with machine learning on identifying ships from satellite photos. It could be, this was taken from a challenge that was done for machine learning. But you could easily see maybe a defense contractor or someone else wanting this, an application like this. So your task here is to identify ships. So what you're going to end up doing is probably a semantic segmentation task. I have this set up here where you can see what the image looks like in the ground truth. So running this on Sagemaker, using default options for their for a semantic segmentation, you'll be stuck with ResNet 50 or ResNet 100. So this leads us into our question about the first thing you have to answer if you're going to be looking at this is, does it make sense for what you're doing to use a custom model? So a lot of times you'll have a better algorithm than what is offered on Sagemaker. In this case, ResNet greatly underperforms with satellite imagery. It's just not well set up to handle it. So using something else is a good option. In this case, something like SegFormer is would be rather useful. It's also nice to remember that there's going to be more cutting-edge tools available if you're going to use a custom model. AI, at least right now, is moving really fast, so there's a lot of things to kind of keep ahead of the curve by moving on to using something custom built rather than the default offered options here. Next, once you've decided that this is the course you're going to follow, as we would with this example, you're going to need to start by building the scripts. So you're going to need to build at least two scripts. One's going to be for training, and one's going to be for applying the model to new tasks. I would assume you're probably going to be using S3 for your data storage, and that your script is going to be pulling the data from a bucket. It's not strictly necessary that you use S3. There's plenty of other options available to you, especially through AWS. It's mostly you want something that can easily something that you can easily access in the Docker container. In order to load it up and train on it. So for the training script, then when you execute your code, it just needs to train a model and then save it to S3. This process will probably take a while. You can use pretty much any library you want, provided you install it with Docker. And for the next script you'll need is to fit your model to new inputs. This one has a bit more strict requirements. It needs to be designed as a web application, as it's working as an API. It needs to return an empty status code when reached with a ping. This step's rather important, but not always the clearest in documentation. When running custom models, I've had issues before where I'm getting things like the endpoint isn't passing a health check. Errors like that are coming up because it's not returning something when it's pinged. Then you also need it to respond to a post request to an invocation route with the output of the model and a 200 status code. That's should be fairly straightforward there. It can be done with whatever method you want, as long as you create it as a web app. I have used Flask. That's worked really well for me. So the next thing you're going to need to do is configure your Dockerfile and your shell scripts. This is also when you start putting it together, not where you're going to get tripped up, most likely. So the SageMaker is going to run both the training job and the endpoint in a Docker container. AWS does have some managed containers that'll be helpful for this. They can act as a really good starting point usually. Basically, you set up your Dockerfile, you install your dependencies for your scripts, as well as packaging them up with some shell scripts to run your Python code or whatever code you're using to train and deploy your model. Those shell scripts are fairly straightforward to make. They're only going to be a couple lines when it's all said and done with. The reason I've used them is the way SageMaker works is it's going to run a command through this container. It's going to run a train command to initiate the training process. And that's the only thing it passes into the command prompt. So you need a shell script that just tells it to run the training code when it executes. That ends up being like one line or so. Pretty simple. I'm sure you can find other ways of doing it too. It's just the way I've done it. Similarly, the endpoint is handled with the serve command, and this is going to need to work as a web application. But again, the simpler process there. Next thing you do is you deploy it to an ECR repository. This is where I found I get the most tripped up and where there seems to be the most things that go wrong. What we've used are GitHub Actions. I find they're rather convenient for deploying your Docker container and setting up the image in ECR. So you store your Docker image in your ECR repository, obviously. So the first thing you're going to need to do for this is to set up an ECR repository. Then you configure your GitHub action with a YAML file in GitHub. Within that YAML file, you're going to define your ECS task, and that winds up, at least for us, that winds up being the only real thing that needs to happen in that GitHub action, as SageMaker is going to build the Docker container itself. It just needs to have the image in ECR. Another important point here, though, is deployment can take a long time, as these images are somewhat large. I believe the one I'm currently using wound up being 12 gigabytes, and most of that is coming from the stuff with transformers and the base image I used from SageMaker. So big thing to worry about there is to make sure you configure your ECR repository to have enough ephemeral storage to hold the container. You don't need to worry so much about the other memory variables. Those can be left at their default amount, but the ephemeral storage is what you want to worry about there. So next we get to training and deploying the model. Simplest method is to use a notebook instance on SageMaker to begin the training job. These are fairly simple to spin up, and the training job, basically you use the SageMaker Python library for this. It's set up to be able to run the training job really easily. Basically pass it a few commands and configure the job. And when you run it, it's going to take a while, especially depending on the resources you provision. Since you're using SageMaker, you get to decide what instance size you want to use for training. This can be beneficial, so you can pick something that has a GPU enabled, or you can go with something that doesn't use GPU. GPU is obviously going to be more expensive, but you're going to get a lot more out of training in terms of how long it's going to take you. The next thing you want to make sure you're doing, though, before you run this, is you want to make sure you're saving the model to S3. Otherwise, you can easily end up training a model and having a model that doesn't save, and you just had 2 hours of an instance running and you have nothing to show for it, which is not what you want at all. So make sure you save the model to S3. Next, you deploy the model to an endpoint. This is similarly pretty straightforward, though you have to go through a extra step of making an endpoint configuration. This is, in the long run, pretty helpful, though, as you can deploy endpoints kind of directly from your endpoint configuration. It allows you to, at least when you're doing testing or in production, to deploy an endpoint from a configuration, run through all of this, do whatever work you want to do, test front end, test back end processing, or your data flows with your endpoint spun up, and then you can spin it down and leave your endpoint configuration up, and then you can just spin up from the endpoint configuration. Similarly, you leave the model laying around in S3. Even if you remove the endpoint configuration, you can recreate it. That's not that big of an issue. And the endpoint can be accessed just like any API, provided whatever you're using to access it has the right credentials to do so. All configured through IAM. So going back to the initial example here, using a better sort of model for semantic segmentation of satellite imagery than what we'd get from ResNet 50 or ResNet 100 here, we'd be able to expect a far more accurate outcome here. We could also, if we had more that we wanted to do than just finding the ships in an image, we could apply that to the endpoint. So we can figure out different sizes, things like that. So things of that nature can be really helpful. So you wouldn't necessarily have to run that stuff through lambdas, but it could be difficult on your front end depending on how you have things set up. So that's always something to consider. So some helpful things to keep in mind. So long as you have a model, endpoints can be spun up and down from anywhere using Boto 3. And also assuming you have the right IAM permissions where you're attempting to do this. So because endpoints can be rather expensive, depending on your use case, you can save significant amounts of money, especially if you're going to do batch processes. I've used things like lambdas with a cron job to shut down endpoints in case I forget to. Things of this are just, I guess, best practices, things to kind of do to keep what you're working on in check. ECR and Farsight can also be a bit touchy. But the important thing is you don't actually need to use an ECS cluster or ECS service when you're setting up your YAML file to run the job. So it simplifies things. I've had a lot of issues creating the image in Farsight, in ECR, and I found that the most effective way is to rely on Sagemaker for that. There's also a lot of alternatives in how you can handle different parts of this. There's no reason you necessarily have to use a GitHub action to deploy to ECR, but I use it, and the people I work with use it, as we find it is a pretty effective means of working, and integrates nicely with GitHub, which allows for some good version control. So overall, in the end, what this is, we're going to get a structure that looks like this, roughly. So you have your project repository on GitHub. You use a GitHub action to create a Docker image in ECR. From there, you use your Sagemaker notebook. This will deploy and initiate. Deploy the image and initiate commands. It'll build your Docker container from the image in Sagemaker. Then it'll create a training job, which will build your Sagemaker model. Once you have your model built, you can then just easily, from the notebook again, deploy it to an endpoint, and that endpoint will work just like any other API. So it'll fit pretty naturally into whatever you're doing. So, a significant portion of machine learning projects may want to utilize custom models in Sagemaker. There's a lot of reasons we went over for that. It can be done through the network I just showed earlier. Basically, you just deploy it to your ECR repository, run your training jobs, and deploy your model. And then once set up, you can get far better model accuracy than what is available through Sagemaker for your specific task, unless you're doing something that one of Sagemaker's pre-built AIs is useful for. All right, thank you all. Thanks to Spark for hosting this, and thanks to AWS Michigan for giving me the opportunity to give this talk. If anyone has any questions, guess.
Have you used MLflow or any kind of ML lifecycle tool integrated with Sagemaker, and how doable?
I have not. I would assume there's a lot of options available. Sagemaker is kind of like it's got a lot of freedom for what you want to do. So it would be something worth looking into, but I've not needed to. So,
Thank you.
Hello. If I were a complete noob to Sagemaker and I wanted to get started in learning it, what would be the best resources to do so?
Okay, so I would start with saying picking something simple to do if you just want to experiment with machine learning and build something cool. I would look up a tutorial for some AI model on Sagemaker that you'll want to do. There's going to be a lot of documentation out there. There's likely going to be a tutorial. They'll have suggested data sets that you can use, and follow those instructions. When you get through to the end of it, it'll probably, depending on how experienced you are, it'll probably take you several hours, but you'll have a decent understanding of how to at least build one of their out-of-the-box models, and then you can look at building container extensions and things like that.
Thank you.
Thank you. Just a quick comment to address his question. Quick comment is that Sagemaker is free to use if you use a non-GPU version. So it doesn't come with much cost. My question is there other alternatives to Sagemaker out there from other kind of cloud providers?
Yeah, I know Azure has one. I'm fairly certain Google has tools available too. I haven't really looked too much into them, though I know they exist. There was a time I was experimenting a little bit with doing some TensorFlow stuff in using Google's tools. But yeah, they exist and they're out there.
Do you recommend try those out, or Sagemaker can do?
I mean, I think it just depends on what you want experience in. I mean, I haven't seen significant price differences when I've researched them. And kind of at the end of the day, they're all different tools to accomplish whatever task you're doing. So I would consider, what's going to be the most commonly used, or if there's at your place of work or with a client they're using something specific, look there. But I've had good success with SageMaker and I like using it. So
thank you.
Thank you. First of all, I appreciate the tip that the non-GPU version of SageMaker is free. I didn't know that. But assuming, I want to go back to costs, assuming you were using the GPU version, like what, are there one or two things that you wish you had known before you started about like sort of costing or billing surprises, things you should look out for?
Yeah, so in my experience, there's a lot of like, it's not always clear how exactly they're charging. At first, I was expecting them to be charging based on how much data you were sending through, but the endpoints are, I mean, at least if they're non-asynchronous, they'll be charging the full time it's spun up. So being careful about what you're using. Using safety precautions is always a good choice. Using the minimum size endpoint for what you're doing, if you're just testing and not worried about it taking 30 seconds to run a request versus 3 seconds to run a request, is a good idea. Things like that. Getting training data from ground truth is very expensive, but it, depending on your project, it is kind of invaluable because data is the big key for machine learning.
Earlier, you also said, this is a new topic, but that Fargate and ECR can be, I think you said, touchy. Maybe you said twitchy.
Yeah, they are.
Can you elaborate?
Yeah. So we spend a fair amount of time trying to get an image deployed to Fargate and ECR, and we finally got it working. This being the people I'm working with on my current project, so we get it working, and it's functional for months. And then we're making an update to test out some new options for pre-processing to hopefully get better results. And without changing much of anything, other than switching around some buckets that got referenced, it broke, and the deployments just started failing, and failed from trying to deploy or trying to spin up the image. So we ended up with finding a workaround where we don't necessarily need to spin up the container, build the container from the image, and that we can handle that through AWS, through SageMaker. Yeah, through SageMaker, sorry.
Very interesting. Anybody else?
So I have a follow-up to the starting from scratch and learning. Of course, following the tutorials and paying attention to what they recommend, I'm interested in that. But some of the things about, since there's so many different languages and debugging at different stages, and the things that might seem obvious to you that maybe that. And I'm wondering, do you test a little bit your scripts on a local instance rather than could you speak to some of that stuff, please?
Yeah. So with these custom scripts, I test them on a local instance first. Especially the training. You don't necessarily have to finish the training, as it might light your computer on fire. But basically, you get going on it, and you'll know if something in there is broken, if something's not going to work, and then you can fix those issues. There are some slight differences that might cause issues when you deploy it. Endpoints are a bit trickier since they're spun up from a web app, but they also need to deploy from their S3, from the model that's stored in S3. So that's where things get tricky, but you can always deploy it to a really low-cost endpoint. You can even deploy it to one that doesn't necessarily use a GPU. Obviously, if what you're doing needs a GPU, it's going to break there, though. But you're kind of stuck in that unless you want to spend some time kind of messing around to get the deployment to work on your local system. Try it out, and that But yeah, good question.
All right, one other last quick one. Just as a thing, if instead of jumping right into a big model, is it something where on SageMaker I could just run some computations in Jupyter Notebook from some library that I could pip install and because I can think of some quant-lib things in the finance world that are in machine intensive that I could just try out. You could work with that. I mean, like, really when it gets down to it, though, deploying into if you're looking at building a machine learning model or something like that, a lot of what you're doing in SageMaker is going to be no different from using a basic Jupyter Notebook, unless you're actually deploying a training job and spinning things up with an endpoint. So.
You mentioned how much you love GitHub Actions. That's something we have in common. But at the risk of losing all of your certifications, so why not any of the AWS code build pipeline type stuff?
So initially, I was experimenting with deploying this with just using from CLI. But I was running into issues with the size of the container. And so I just I asked around what should I look at doing, and some coworkers suggested using GitHub Action, and that's what I went with, and it's worked. While it can be touchy, it has worked well as far as allowing collaborative work and stuff like that.
Thank you. One thing I wanted to mention, just in case it helps someone else, in GitHub Actions, you can now define GitHub as an OIDC identity provider in your AWS account, and you don't have to actually put any credentials into GitHub, even as secrets.
Oh, okay.
You don't have to do any of that now. Everything you look for online is people give you tutorials. Here's how you do stuff in GitHub Actions with AWS. First, create a user. Then, dump your keys over here. Not necessary. It's actually quite nice. It's all role-based.
Oh, okay.
You create it as an identity provider. You give it a role to assume. Okay. You mutually authorize that behavior. You do have to install the AWS Identity Provider app in your GitHub org, right? But it's very nice because there's no credential problems at all. It makes people very happy.
Oh, cool. What is GitHub Action?
One of you guys? Sorry.
My understanding is it basically deploys your your code directly into AWS, one of their services. Here we're using ECR and Fargate, but that's what I have experience with GitHub Actions.
CI/CD, basically.
Yeah, you could do that.
Anything with it. It's like
Yeah.
directly said, like a workflow engine.
Yep.
You can do like a workflow engine. You can do almost anything with.
Yeah,
Build, test, create war files, create deployment bundles, put them here, there, and everywhere. It's quite nice.
Yeah.
And it's all driven by a YAML file, put in a well-known location in your GitHub repo, and it just happens.
Yep.
There is a limit on the minutes you get, I think, if you don't have a paid-for GitHub account.
Yeah.
So many minutes.
Yeah.
Okay. Yeah, so then be careful if you don't have a paid account, then, because you can run into limits there pretty quickly, depending on what their minutes are, given that you're deploying rather large images.
Something else Thomas said spurred me to ask. And you were talking about the size of your jobs. Can you elaborate a little bit what the transformers do to generate such large? Is it more than just an array of numbers, or what? I mean, what is going on?
It's an
there?
array of numbers that is incredibly large. It's like, so there's like millions of parameters in there, there's millions of parameters. It's designed to fit all of them, and it becomes a mess pretty quickly. It's been interesting with such a large image for Docker, since normally they don't get that big.
And that's kind of what you're finding. And that's not, maybe you're way out in the frontier here. I don't know.
Yeah, who knows?
Yeah. Okay, well, thanks.
Hey, no problem. All right.
So no demo then.
I mean, I thought about it, but I don't want to hit enter and stare at everyone for 2 hours. All right.
Thank you.
Thanks.
Thank you.
I hope you all